Okay, good afternoon, everyone. Today is almost one of our last sessions. So, as you see on your syllabus, the due for submitting everything is actually from today to December 1st, but I extended. So, the reason for extension is like you might get some feedback from me either today or on Wednesday. So you have some time to fix that, and in case it needs some improvement, you do improvement. So it's actually better if you present today because you have like almost 1 week to fix the thing and resubmit. Also today you see I post the assignment grades. So in case you have issues about your grades, you can just reach me either in next class, my office hours, or through Zoom. In case there is no final for this class. In case you think you deserve a better degree and a better grade, and this course is much harder than what you expected, that's fine. I already knew that this course is kind of hard, so just reach me. I might give you some extra thing to do if you want to. Hopefully you don't need that, but just in case, because I'm pretty sure this is a tough course for learning, but it shouldn't affect your grades. So in case, but I don't reach me later and ask me just round it up or get a better one if you didn't do anything. So some of you were very active in the class, some of you attended the challenges, you guys have bonuses, but in case you need some extra bonuses that could help you, so I might give you some extra assignments. But hopefully I don't expect I expect most of it needed. Just let me wrap up. So in this course, we start to understand first concept, then we wanted to see why we need a big data environment, why we need Hadoop environment. So we did some parallel processing through Python. You might remember it was very challenging, even for very basic, like finding the means and the maximum. So then we try to use Hadoop ecosystem. So we did some data management thing through, let's say, Pig, which is somehow looked like SQL. And then we went to we focused on big data programming. So we started learning Spark and PySpark more specifically. So we set up in two environments. One was AWS, and another one we just used Databricks, which was much easier. So because you don't have to do some basically ecosystem setup. So in Databricks, the ecosystem is already set up by the company. So and you as a business analyst, you might work in an environment that you need some. Maybe Databricks is enough for you, but it may not happen like Shashank. So he had to know some background knowledge. So what those nodes means and how to set up the ecosystem. So you have some knowledge of how to set up a Hadoop ecosystem, but in future, I mean, the technology is developing, and maybe some updates. Maybe you need to update your knowledge frequently. But I'm glad that you have some knowledge either from why you need Hadoop ecosystem and how to set it up and how to do programming. So you have a wide variety of knowledge. Again, today and next session, you guys present. I'm not sure how many percentage of you want to present either today or on Wednesday, but I already have the remainder of the Kafka session ready, and I'm going to upload it. So in case you want to need more about Kafka, maybe you can reach my, I posted this week. So, and Kafka, I might use it in the next course, which I'm going to teach about how to set up a blockchain and how to design cryptocurrency. So probably you see more of it in that session. And again, if you're graduated, you don't have to just pay and register for summer. You can just let me know. Since you already have so many background knowledge through this course, I think that course might be much easier, because like similar to Hadoop ecosystem, you should connect to a host, like do some kind of programming and like do some parallel processing, those communications that you at least have some idea about that. So that course is highly recommended for you. This is what I know that what I'm supposed to say. Do you guys have questions, either people in the class or over Zoom? Yeah, I don't see any other questions over Zoom. So, so Kafka is optional. I think it's a little above the class level. You can follow the like assignments or instruction that I provide, but you don't have to submit it. It's just for your own knowledge. Okay, having said that, who wants to, from you guys in the class, who wants to present today? You, Kirti and Sahan. Kirti said sooner. So we have to, and please finish by 15 minutes. People over Zoom, is there anyone who wants to present today? Yeah, Kirti said sooner, so I give priority to Kirti. Let's see. Oh, there is no volunteer over Zoom. If I knew that just 2 people, maybe I could teach today, but no worries. I will post the Kafka session. Later on, people over Zoom, if you comfortable with presenting in class, please just let me know. So, Kirti, could you use a flash memory and just, okay, that's good. Behind this one. Yeah, maybe you can just open one of them. Yeah. Cool. So for the people who present today, I will be much nicer because you're enough brave to present sooner. So cool.
Actually, I haven't like completed my whole process, but then I thought it's better to present.
Yeah, that's different.
So I just wanted to start off with the fact. Did you know that 1 in 4 employees they actually quit their jobs this year? So this statistic is of October 2021, and it's from a people analytics firm called Wiseyear. So with that in mind, I would like to start my presentation, which is on employee attrition. I'm Kirti. So what is actually employee attrition? It is a departure of employees from a company or from an organization at any point of time. So it can happen due to many reasons. It can be voluntary or involuntary. It can be due to the termination or poor working conditions, or it can be due to retirement, a lack of career growth, maybe managerial conflict. So there are many reasons. But what is the impact? The impact is really huge on the organizations and the HR department. So they spend a lot of time in order to serve their customers. But once they get distracted from the fact that they have to hire and train employees like all the time, it gets really burdensome for them. So this is according to a statistic that the healthy turnover rate or attrition rate across worldwide is like 10%. So anything about 10% attrition rate is really bad, employee attrition rate. So now coming to my business case. So I have chosen this particular company, which employs at any point of time like around 4,000 employees, and it suffers from an attrition rate of 16%. So like I've given the statistic in the previous slide, 10% is a healthy rate. But then if it is about 10% per year, it's a huge problem. So what we are going to do in this issue is that we are going to identify the variables, the driving variables that impact or that forces like that we should focus on in order to reduce the attrition rate in any organization. Also, keeping those in mind, we would like to recommend any changes that we can do from our end, or we can suggest to the HR management or the organization as such, so that they can take care, which are the controllable factors that they can take care of, so that they can curb the attrition rate. Now, the approach that I have taken for the analysis is pretty much a crisp DM approach. It starts with data understanding, where I have taken all the set of, so procured from the data from CADL, went about understanding the data, and then through the EDA process, I have gone through the univariate and the bivariate analysis, and also some of the multivariate analysis, how the variables are correlated among each other. And also the data preparation phase, where we convert we do the one-hot encoding, and also a lot of transformations from one data type to another. And there was also an issue of class balancing, which I'll explain about. And then I went on to model building, and I have chosen 3 algorithms: logistic regression, decision tree, and random forest classifier. Then I went on to model evaluation, where I've primarily made use of recall precision, recall or sensitivity, and I've also made use of AUC and accuracy as my main metrics. I would be explaining why I chose those 3 as well. Now, coming to data understanding, the data was partly procured from the HR databases, where the HR data consisted of a lot of employee demographics and their current existing employee-related, job-related information, education-related information. And also, the data was procured from a survey that is conducted by the manager. A survey that was conducted by the organization from the manager point of view and the employee point of view. And also, the biometric data was taken, which has the swipe in and swipe out times of the employees. So all this data was, so basically the data set was procured from CADL. Now the way I've looked at missing values is that when I combine all of the percentage of the missing values, it was hardly less than 2% of the whole data set. So instead of imputing, I chose to remove all the missing values, because there's hardly 1% of any of the categorical or numerical variable that is like below like 1%. That's above 1% missing value. So yeah. After that, I went on. Yes.
For those 5 variables, you had less than 1% missing, right?
Yes.
So, and you said you didn't impute them?
I did not impute them. I chose to remove them.
What was your reason again?
So the reason was that because it was less than 1%.
Okay.
It's not. It does not make a significant difference, like in the data set.
Oh, okay. So
yeah.
Yeah. Okay. Now
I just removed them.
Okay. I understand.
Yeah.
So so you use a Spark R?
Yes. Okay. Yes. So the technologies that I worked on is partly Spark R and PySpark. So it was really challenging for me to use PySpark because I've never used Python. So I learned it through the process. Mostly I use PySpark. And for some of the visualization, I had to make use of local R, because it was challenging in Spark R as well. Like for some of the algorithms, like for this, I made use of the local R version rather than the Databricks.
You know, for this project, it's fine, but at least for your final submission, you should have some visualization, either PySpark or Spark R.
Okay.
But don't just send R.
Okay.
So because I want to know advanced programming, so I want to see some visualization from Spark R and PySpark.
Okay. Yeah. Okay. So I have made some visualizations, but I did not like put them on the PowerPoint, like in PySpark.
That's fine for PowerPoint, but it should be in your project.
Yeah, it's there in my project. Yeah. Okay. So then I went on towards feature selection. So I wanted to choose only few variables. Like there were a lot of variables, and I was sure that there's going to be overfitting issues, so I had to cut down the number of variables that I'm putting into the model. And I saw that some of the variables like years at company, the total working years, average work hours. So all these, they fared really well. So they are impacting this particular graphic shows that they are making an impact on the target variable.
And also, it's just generally speaking. Try to work on cuteness of your figures. They are really good figures, very informative, very good. But like, for example, look at the function, our function that we put there.
Yeah.
Maybe or some of the words mixed with the figure.
Okay.
Maybe you can work on font. But these are really good. It's just what you can.
Okay, sure. Yes. Thank you. Okay. So correlation and heat map. So this was also one of the tools that I used because I wanted to find out if there was correlation among the variables. So I wanted to remove the variables where there was like two variables. If you can see in this particular figure, you can see that the total working years, and there's one more called years since last promotion. So they had a high correlation rate. So what I did was I removed one of the two variables because like we don't want any multi-collinearity issues among the variables.
So Katie, that's very good thing. What I can suggest, maybe let's say you indicate. I'm not sure if you end up in KPMG, but let's say in KPMG they give you like 2 million reports.
Yeah.
You cannot use a local machine. What can you do, which I recommend to do for this project too? Do a random selection from your data, totally random. So maybe here in this course, maybe you can pick 99%, that's fine. But at least to use the random function.
Okay.
So maybe if you use a very higher random selection, it will be exactly similar to this. But at least I want to be included. Okay. So this is a proper way of, because Spark R and PySpark, they are still developing. So the reason I'm telling you, just update your knowledge every year.
Okay.
Having said that, you want to it's totally fine if you do a random selection of the reports and then download the reports and then use local R.
Okay.
I think this is a proper way.
Okay.
And that makes a lot of sense.
Okay, sure.
But yeah, because practically, let's say in KPMG, when they give you like it's impossible to do that. But if you do the random selection, you said because in local machine you have more function, more packages, everybody buys it from you.
That's right. Yeah.
Please do this for your project.
Sure. Thank you.
And then even it's good if you select 99%.
Yeah.
But at least just put the percentage.
Okay. Sure. Yeah. Okay. So these were some of the variables that I found out to be really significant. And so we have answered like one of the business problems that we identified, which is the driving factors. So what are the driving factors that impact the attrition rate? So these are some of the factors like years at company, total working years, average work hours. So all these fared like really on top. So before going to the model building, there was an issue of class imbalance. So you can see that the attrition here, the one represents those who left the company, and the 0 represents those who are still with the company. So obviously the HR database will have records of most of the records that consist of only those people who are in the company. So there's very few people. The ratio was like 1:5, which is really high. So for that purpose, I had to choose to oversample the minority class because because then the model would be then biased if I do not use oversampling technique. So I would talk about it in my model evaluation. I would show what are the results that I have obtained with class balancing and without class balancing. Also, I performed one-hot encoding for the categorical variables. So these are my results. These are the results that I've obtained. So I would like to explain why I chose recall or sensitivity as one of my primary metrics. So here our objective is that the organization or the HR management has to clearly identify the set of employees that leave the company in an efficient manner. So that is nothing but the true positive rate here. So the true positive rate is recall or sensitivity. So that is the reason I chose recall or sensitivity, which clearly distinguishes the number of employees that leave the organization, that potentially leave an organization. So I wanted to choose for that reason the sensitivity as the primary metric, and accuracy definitely because it clearly defines like how efficient the model is, and AUC for the reason that it shows how better it performs than any random model. Like for any random model, it's like 50%. If it is above that, then it's really good. So random forest is the, so you can see without class balancing, you can see that the recall or sensitivity rate. So the system, the model was unable to identify the minority class, and so there was really lesser percentage of true positive rate. But then if you see with class balancing, the rate is really good. And the random forest, I chose random forest to be the best model of all the others because it has a really good accuracy as well as a true positive rate and also AUC. Now, so we have identified the best model. What next? We want to if we give the model to the organization, they're not going to agree with that. So what they want is results. They want to see who are the employees they need to look at in order to get the results out of it. For that purpose, I chose a Gantt chart. Here, what we see is that if we sort all the, so I sort all my evaluations in decreasing order. And if the HR or the HR management concentrates only on the top 30% of the records, they will be able to identify 75% of the employees who are potentially leaving the company. So this is one statistic that I thought it's really important, especially from an organization point of view, because they are the ones who need to spend money or their budget and allocate accordingly in order to, make the employees stay in the organization. So lift is also one of the very important metrics. So what we can see here is that if we do not use the model, so what is the difference if we do not use the model and if we use the model? If we so we are concentrating on the top 30% of the records, top 30% of the employees, and if we look at that, we can see that there is a lift of 2.5, which means that we compared to the random selection or the random model or any random chance, we have a 2.5 times better efficiency if we choose to work on this model, if we choose to implement this model.
But these are really good figures. I really love that we included them. But could you explain for your friend what you mean from efficiency or performance? What 2.5? What does it? How you calculate it?
So this actually I made use of Excel for this because I did not know how to do it on PySpark.
No, just say you said the performance of the actual model is 2.5 more than just tossing a coin.
Yeah, so yeah.
How it comes from? What does 2.5 mean? Let's say maybe the accuracy is 90%, otherwise 40%. Is it like that?
It's not based on accuracy. So it's based on my evaluations. It's totally based on probability. So like I mentioned, the Gantt chart, I have sorted the my evaluations according to the decreasing order of probability. So based on that, like if we so I don't know how to explain. I have a Excel chart and which I can show like at the end of the session. Yeah, like it's a very big process. Like I just follow it.
For your friends' information, you don't have to teach it. So if you have something, that's fine.
I can take a session like next if like it's a whole lot.
Just thinking about weight and gain. These are really good measures that you can have for your analysis.
Yeah. So okay. So now there's one more thing we would like to explore. So how can the HR or the organization identify from their point of view, like who are the employees that they should take care of, or they should make changes to their workplace or their work lifestyle and whatever, in order to make them stay in the organization. So here according to the EDA or the exploratory data analysis, I use some of the visualizations, and we can see that the employees aged 32 and below, they are more likely to leave. Also, the employees that have worked for a total of 7 years or less, they are more likely to leave. So these are just some of the pointers for the HRs in order to just understand what kind of employees might potentially leave the organization. They might not be completely true. It is totally likely. It is likely that this kind of employee can potentially leave the company. Also, employees who have fewer trainings and employees who have spent lesser time under the same manager. So over time, employees tend to form a bond with the manager, and they would definitely would not lose a manager who is like really close to them. So that was like one of the things that we found out. And also regarding job satisfaction and environment satisfaction, definitely those who are have low levels, they are more likely to leave the organization. And the average work hours is definitely another situation. So those who have worked for more than 8 hours, so the average work hour is like 8 for any organization. So if they work for more than 8 hours, they're likely to leave. And also if they have rated a lesser work-life balance, definitely they're going to leave. So these are the recommendations based on all the analysis that we are going to give to the HR management. They need to improve the work-life balance and the environment. So there needs to be more flexibility in terms of work, and they should definitely avoid any kind of overtime hours that the employees need to put in. And the definite business travel is also another aspect. Then people who tend to leave, they have been traveling more often in the past. And also having a stable manager really matters, because they get to they tend to have that bonding for a longer period of time. And relevant training has to be given, especially in case of younger employees. If they are directly recruited and then they're deployed into the job, they definitely don't make a good impression. Employee engagement initiatives are another matter of concern, and those who are this is a concern for those who are single and who are definitely like into the job, like kick-started their job. Employee recognition, and managers definitely need to identify the talent at the right time. They have to provide incentives or rewards accordingly so that they feel recognized. Now, for any future employees or the changes like in future onboarding or the hiring process, they should definitely employ people who are older with recent experience. For younger people, they can employ younger people, but they need to make sure they train them properly. These are some of the references that I used. Before going to the end, before concluding, I would just like to show one of a sample dashboard that I created for this data. Like, it's not really complete, but then it just looks like this. I can show it if you have the link. Yeah, I have the link. Okay, that's good. Yeah, maybe you can paste it. Oh, you give access just to yourself, I guess. Oh, is it? Okay, then I just like. Oh, that's fine. It says it has access.
maybe you can sign out to me and
Yeah.
sign it yourself.
Okay, how do I access
Maybe you
this
can
again?
paste the link again.
Yeah. Oops.
Don't say.
Yeah. Okay, where do I have the full view? So this is like just one of the dashboards that I created, but it's not complete. I'm just like still working on it, but yeah, however it is, it still works.
So let's
So-
for example, click on manufacturing. So go
Okay.
to that bar chart, go down to
The department, you mean?
the job role,
Okay, job role.
and click on manufacturing.
Okay.
Okay.
So
And
it
let's
just,
compare it with the research sign. So you click on it. Oh, not big differences. Interesting.
yeah. So if you want to like check the,
Check female and male. So let's see what happens for the different genders.
yeah. So if I just like click on the females,
Uh-huh.
so these are some of the results. Like I haven't like derived any insights from it. I just like built a sample dashboard for now. So yeah. And we can also change the age group here. We can put different age group and we can check the results for that.
Yeah, one of your, I mean, recommendation or result was about age group. Maybe you can just put two different age groups.
Yeah, we can try that. For maybe age group, maybe till 25. Okay.
So do you have the number of people who left? Does it show that?
The number of people who left. So the attrition rate is given here on top.
Right, right. Yes, under the,
I'm unable to move that actually.
yeah, you can move it. You can put it
Yeah.
in a random place somewhere.
Okay.
That's good.
Yeah, so it just shows the attrition
So
rate for those.
let's change back to number 36 to 150.
Okay. 36 to 50.
Yeah, it's drastically different.
Yeah, the attrition rate is much less. Those who are younger, they tend to move jobs more often. So
Okay, that's really cool.
yeah. So that's it. Thank you. Thank you so much.
So my general comments, very good presentation, very good visualization, good figures. I really love your analysis.
Okay.
So for what you did in R, go to Spark and do just Google how to handle some reports and download the report and put your code.
Okay.
Don't change anything else.
Okay.
Also, but you need to have some visualization in Spark environment. You need to have some programming there. I should see it in your notebook.
Sure, yeah.
That should be there. And maybe let's see, maybe you can work on the variable importance too.
Okay, sure.
So because it helps you to enrich your results, maybe you can maybe do prediction. You can say, okay, I use this, and these are the most important variables. And maybe based on that, you can do some inference. But overall, a very good presentation. Thank you very much.
Thank you so much.
Yeah, you guys.
Sorry, I'm late. I just got in a car accident.
Oh, wow.
So some guy just hit me from behind too.
So
Yeah.
How's your car?
I don't care about the car. I didn't have my good car, so like I just had like my beater. Huh? Yeah, I don't know. It just hurts now. Just started.
So I hope the guy has insurance, otherwise fixing the
Well, in the
And-
state of Massachusetts, it's like whatever. Like you're gonna get your car fixed anyway. Because I have insurance, so
Yeah, I mean, insurance is your insurance for sure.
He definitely had help. He hit you.
yeah.
It's free for you to go ahead. And you might think your arm is hurting. You need to go get it checked out. And all this cover that too.
Yeah, I think. Do the check on it, please. See. Because it seems it's-
It might just go away because like it didn't hurt at first, but like it's just starting to hurt now. It wasn't like a huge impact, so but I'll just
So
have
I'm telling you something, don't do it, but in the US, if somebody hits you from back, you can rip him or her off from my side, but it's not what I recommend, it's not a good practice. So you don't do it from your side. Yeah, because if you hit someone from back, everything is against you.
No, I was talking to the officers, police officers. Don't worry, it's just like as long as you're okay. So it wasn't such big damage. It's just like my back. I mean, my rear bumper. It's off, but like yeah. No, they're gonna fix it. It's just like I'm leaving in like a week. I'm not gonna be in the U.S.
Oh,
I just have to like figure it out like as soon as I can today or tomorrow.
all right.
Okay, everyone. My name is Sahan and my friend Amarildo. Today we're going to present our project for this course. The California housing prices is chosen as our datasets because this is actually predicting houses prices is like a highly controversial issue all around the world because it's absolutely dependent in too many variables. In each dataset, there are some different variables have considerable level of impacts of house prices. Due to the time limitation, we divide our presentation to just some parts: abstract introduction of our data sets and main questions, machine learning models, and visualization, and the last of that conclusion. But the methodology and the definition of each methodology is written in our PDF files. As our abstract, we're going to check the importance of the problem. House price prediction is absolutely important because there are many stakeholders in this regard, including in property investors and people who want to buy or sell their houses, because they have to actually have a little bit or more than a little bit prediction about the house price for deterring from losing their money. And some people put their actually future investments in this industry. So we have to find efficient machine learning models for predicting the house prices. As our introduction, housing markets have a positive impact on a country's currency, which is an important national economy scale. And it's should point out it's absolutely important in our country as well. An increase in house demand occurs each year, indirectly causing house price increases every year. For example, U.S. nations experienced too much house prices due to the pandemic. So actually, it shows us the importance of predicting price. The data set is chosen is about California houses prices, and in these two tables, we just showed some main information about the data set, including the variables that we checked containing longitude, latitude, housing, median age or total rooms, and on the other hand, income for householders or something else. Okay.
So these are for like different variables. So we have the longitude, we have latitude, housing median age,
Yeah.
total room, and
Just a description of our data set, including maximum, minimum, and standard deviation for each variable. And we should point out, in like other data set, we had some null values, and actually we
So I have a question about the median income. So it's about
householders.
median, there's like a second table,
Yep, here.
column 3
Mhm.
is median income. So the mean is 2.8. What does it mean?
Okay. So, what they did is just like, they just took all the median, so like on how much like every household was making. So yeah, the numbers were a bit weird in a sense. So like they were starting from zero and not from like from 0 to 1200. So my assumption was that the 1200 would mean like $120,000, and then that's why they started with like the small numbers.
So in median income, so for each house.
Oh yeah, this is for the median income. Yep.
So the median income and the minimum income is the mean.
Yeah, point
Mean of the
zero.
median.
Yeah, 0.49999.
Actually, you have a good explanation with the still here. Please check it. So maybe it's in thousands, and I guess it should be annual income, not just like
Yeah.
weekly or monthly. Just check it and just maybe because people might ask. These are the people who doesn't know anything about programming. They focus on these things a lot, and they might say, "Why is that? Why
Okay.
do you think that?" Okay, cool.
Yeah, we'll check that. Yeah.
And we are facing some main questions, and during this project, we are trying to answer this question, containing using our 3 different machine learning models, including random forest, decision tree, and linear regression. There are some machine learning models that we will indicate them, and these are for the future projects or future study. And during the project, we evaluated the accuracy for each models. And at the end of that, we compared the machine learning models for finding the most most valuable machine learning models. Yeah.
So we were going to talk about on the next slides, we were going to talk about the models that we use and the visualization. So what we use is the linear regression, decision tree, random forest, and we were using Databricks for visualization. So we're not going to have like a pretty, like you did with all the, graphs and all that. I mean, we have some graphs. It's just like they're not going to look as pretty as.
So for your machine learning algorithm,
Yep.
you use Databricks too?
Yeah.
Visualization Databricks is used to.
So Databricks is for both of them?
Yeah, for
Yeah.
both the visualization and for the
All of them
model.
is done by Python.
Okay, so we have the linear regression, and what we did here is just like with the variables that we use, it was the housing median age, total room log. So like we had to create a room total room log because of the we had to do like a summary statistics because all the numbers were a bit different. So like we had to complete that. I mean on the can you just go to like the
PDF file?
yeah, the one that I did the codes and stuff. So from the
You want to check codes?
yeah, just the codes. Sorry, I can't remember like all of it. There's just like so the room logs. Where did I put them? Okay, right here. So yeah, from we had to just create this variable like total room. Sorry. Where? This could be somewhere here. Nope. Yeah, what's over here?
For regression?
No. Total room logs. So like why I created the other one. Where did I leave it? Okay, right here. Okay, right here. So we had to like we use like a logarithmic scale just so we can normalize all the data because they were a bit, off. And then this is what it looks like after we created this variable, total room logs. So from that, so like after like we normalized all the features and then used all the variables, we had to do like a standard scalar just so we can compute like the summary statistics. And then we ran the test. We ran the test with choosing the standard scalar. So like after we put them all in a feature column. So like what we do is like we get all the variables that we need and put them in a feature column so the model could run it. And then we chose the standard scalar, which was just a unit to standardized deviation for all of the different features that we selected. And then we selected the price so we can have the prediction on the price. And from what we can see here is the R squared, it's 51%, which is, and for the test is 52%. It's not the best of models, but from all the variables that we chose, like that's the.
So what comment that I can say,
Mhm.
When I look at your notebook, I can understand you know Firestorm. But when you present it, you don't have to put the codes in it. You can make some cute tables. That's more than enough. If you want to show off to somebody who did PySpark, you can just put the PySpark logo. That's enough. So you don't have to show all of these codes.
I have for all of the models, like I've put some of the, I just wanted to show like the results.
Yeah,
so should I just cut to the part of the result?
The purpose of presentation is just, there's like some major reason why you present. One is showing, transferring the information, another one showing off your knowledge. So, which for showing off your knowledge, you don't have to put the codes. Just if you put the Spark logo, that's enough.
Okay, so
it's better to be more minimalist.
So should I, just for like the
Yeah,
future
that's
reference, should I
enough.
just put in like the R square, like the number from the R square, so we
for
can
the
see like
results,
just the
make
result?
some cute table and just the results. But in one, if you want to show off that you know by Spark, you can put the logo there.
Okay.
Or maybe you can put the headed logo that telling people you are an expert in that.
Okay, you're right. And then we do the decision tree. So we just wanted to see, but this was, we put it on we chose a different independent variable, which was like the ocean proximity. Cause like we were trying to do this with the price, but we were getting like 5%, accuracy from the price. And then we changed it to the ocean proximity. But I'm going to show it, we're going to show like, why did I chose the ocean proximity on this one? So it means that how closer you are to the sea,
Location of the house.
the
So
location.
except for the house price. So show me your dependent variable again.
Where is it? Oh, wait. So yeah, we chose these house median age, total room logs, and then the median income.
So what was your dependent variable? It was an exact price.
Yeah.
So, and you are not satisfied with that.
For like when we ran the random forest and decision trees, like we were getting like 5%. With
That's different. It's like continuous. That accuracy is different from. You should maybe automatically look down, or because if it's a median price, it's a continuous variable.
Mhm.
So there is accuracy for that, but it's different from classification.
Oh, okay.
So if you want to do classification here, which we have accuracy, AUC, those kind of things, maybe you change your dependent variable from the continuous price value to two classes of high price and low price,
So just create like two different.
Yeah, maybe you can either. Yeah, I should look at the 5% that you are talking about.
Mhm.
If it's RMSE or like whatever those kind of measures, or but if it's if you want to do classification, you can just divide your kind of area into classes. So if it's, let's say, again, I just throw a number. Let's say for houses more than 1 million, you consider them as a high price, less than 1 million low price. So high, expensive, cheap. So you can do that too. But 0.05
Yeah.
could be a good accuracy measure for continuous variable, but again, I don't know how you did that. Just check.
Yep.
Because, Professor, we had more than one or two dependent variables. And the 51% for continuous, I know it's not the best, but the more than other accuracy that we should.
Proximity is like, it's okay for this kind of. Okay, go ahead.
Okay, so you know, for the decision tree,
So
so
I understand the important variables for ocean proximity, how it helps.
so it was the, you know, the rooms, so the total rooms. So now we're not using the logs, the room logs now. It's just like we just collect the variable from the total room, so the median income, latitude on like where the house is located, price per capita income, and population. And we did it on the ocean proximity. So like we had to do like an index for the ocean proximity. I was running the code, but it wasn't letting me. So like it said like I had to do like a string index on the PySpark, and then we did the index, and then we have the ocean proximity index. So where we can see that from the picture here, it shows that it's somewhat accurate. It's like 71%. I mean, 70% for the decision tree. And then we did the same, we ran the same model for the random forest, and we got a 71.5%. Okay, so some of the visualization, we just wanted to see like if the prices were like, you know, normally distributed. And then from these tables, we can see that they're somewhat, you know, we have some outliers here. And also this is a visualization about the average price of the house. And it just shows that how many rooms and like the average price in here, which we can see that.
So could you find a relationship between number of rooms and stuff?
Well, yeah, because like it depends on like how many rooms, because the more rooms you have, oh, it's right here.
So actually, go back. Maybe it could be okay. Price is not related to number of rooms. Maybe it depends on which neighborhood. So here we include the neighborhoods, and it's the reason almost there's a random relationship. You cannot find any basically maybe regression line. So okay, go ahead.
Okay, thank you. In these two charts, we can see the per capita income distribution. But actually, about your question, I wanted to show this first. In the right one, we can see the heat map, and the heat map can help us to find the correlation between different variables. And maybe it actually would be better if you put the heat map before the regression. We can find the correlation between different variables. And for example, if you actually you want to check each variable, for example, price, have correlation with longitude, latitude, or per capita even. And another one, and go back to, yeah. Another one, we can check the distribution for per capita income, and we can see the most proportional distribution is focused between 0 and 100. And in the right one, we can identify the outliers in the graph. For example, per capita income and price of the home more than 6,000 can be considered as an outliers. About our,
Have you excluded that or you just mentioned?
we mentioned in the graph and visualization.
Okay, maybe you just exclude them. You can make it if comment. Just exclude the outlier.
Yes, and in our PDF file, just before the starting the conclusion. Yeah. At the end of the presentation about conclusion, we found that many variables can have considerable level of impact on the price. And in this presentation, 3 different methods executed for predicting the prices, including random forest decision tree and linear regression. For future project, some other machine learning models, including k-nearest neighborhood, can be done, and the results of that can be compared with our results. But other different type of methodologies was written in our PDF file. For example, just actually I mentioned decision tree, and we made some tree in PySpark and executing prediction for each of them, and after that actually average all prediction, and final value for prediction was 71%. Yeah,
Okay, so
to PDF file.
So here, this part, this is could be one of your first slides, because here it's just summary, and you can change this from conclusion to summary, because this is just summary. I think maybe you need to put some inference to what you learned from those variables. The good thing about your project, you did everything with Spark environment. That's a plus, and I like your slides. Yeah, based on PySpark, you have some limitation in visualizations. That's totally fine. I think you can exclude the codes. Yeah. So there is a little room for making it cuter, but in PySpark we have some limitation. Every year they update those packages, but what can I say? Help you? Send me your code and show me where you have problem with dependent variable. Maybe I can help you in coding, so you can, even for continuous variable, you can do prediction.
Yeah. So
Other than you did a lot of before I did like the project, what other I can recommend maybe is you need to work on your presentation skills. It does what I mean is just more exposure. That's it. So it's not there's a magic way. So if you present gradually, just keep it. You improve your skills. But other than that, good presentations, and you're very brave student present earlier. People learn from you guys, so that's a good practice. But no worries. I mean, send me the code. I help you for coding part. Because this is a very limited course, and it does everything from understanding technology, like doing some data management, like in pig environment, Hadoop. So I couldn't do coding, all aspects of coding. Otherwise, this semester should be like we should have like 2 or 3 semesters of advanced with that program. But no worries when you start. So you also can use Stack Overflow. So in that, you just post a question and the community answer. But I don't think. Let me see. I'm not sure if they answer you in today or tomorrow, but if you send me, maybe I can help you soon. Yeah. But Stack Overflow is a place that people just, whenever they start, they just post their codes there and people just.
yeah, I was doing some research like while we were coding and stuff. So like we would go to like I was just seeing like some of the problems that I was having and then just Googling it. And also like some from YouTube videos as well, like the coding. So it's very helpful. So
The reason that you present today is some feedback. But on a very good project, thank you very much.
thank you.
Here, thanks a lot. Thank you. Yeah.
Close the PowerPoint. Yeah. Then and the PDF.
PDF. And
Maybe
maybe Word file, Professor.
what is my maybe this web page?
If I'm not mistaken, I opened the Word file, but I think it will be okay. Yeah.
Yeah, it should.
Thank you so much.
Okay. So let's see if your friends over Zoom. Do you guys want to present people over Zoom? Let me check. Yeah, I don't see any from Zoom who wants to present. Yeah, I mean, thank you very much. It was really a good course. I'm really satisfied with your knowledge. I know it was a lot of technologies, and we just went through the surface of it. So, and you guys almost in the last semester. It depends where you end up. Yeah, maybe you focus on the data management. So you can go back to the sections that I talk about how to data management through Peak, and maybe you should expand your knowledge in that section. Maybe you do work with the big data programming part. Maybe you need to expand your knowledge in PySpark. But as I said, I couldn't just teach everything in depth because otherwise it should take like 2 or 3 semesters. But other than that's very good. Again, I'm going to upload the remainder of Kafka technology. And yeah, keep in touch. Good semester. Thank you very much. Also, in Wednesday, you can present. And I still give you feedbacks for improvement. If you guys upload over Moodle, maybe I cannot give you feedback in the proper time. So, but if you present the class, there's a good time. And I have enough time to read and just give you comment. Thank you very much. Take care. Just clap for yourself. Thank you.